Hit full. Okay, now I'm recording. Is my voice really scratchy? Like, has a lot of interference with it? Or is it clear? Okay, good. All right, so I'm going to start out by going over this one. We're going to find the derivative using implicit differentiation. This is a little bit of a tough problem, so I figured y'all would appreciate going over this and being able to look at something like this. So I'm just going to go over this one without asking too many questions. So you can see. So first off, I got a new screen protector. No, my screen isn't wanting to act right. But you have right here, you have product rule with these two, and then you have chain rule because you have a function inside of a function. So we're going to do x squared times the chain rule of x minus y. So it's 2 times x minus y times the derivative of the inside times 1 minus y prime. Remember, when you take the derivative of anything with y, it's y prime. And that right there is just the first part of the chain rule. So it's plus 2x times x minus y squared. That's the second part of the chain, or product rule. And then this equals, you can take the derivative of x squared is just 2x, and the derivative of y squared is 2y y prime. So there's no real way around this. You just have to simplify and FOIL things out to get everything alone by itself. Believe me, I tried. It just doesn't work. So I'm gonna come over here. Yeah, this screen protector does not want to work. I'm gonna have 2x squared. I'm gonna FOIL this out. I'm gonna use the box. So x times 1 is just x. X times y prime, or negative y prime, is negative x y prime. Negative y times 1 is just negative is just negative y prime, and negative y prime times negative y, or negative y times negative y prime. That's just negative y prime. That's just negative y. And then negative y times negative y prime is positive y prime. Plus, and you can leave this right here like it is, because you don't have any y primes. This problem is from the textbook. Does it look familiar? I get your problems from your guys' textbook that's linked online. That way I can remain topical. So this equals 2x squared times and that's just me simplifying and adding all those up down. So now you have this is just me distributing everything through. And the problem, I don't see it, is number 5 from the implicit chapter in your textbook. So I usually try to keep the numbers right. That was me distributing the 2x squared. You can see how this is kind of sort of wordy. So I like to notice my terms with y prime. That way I get them all on the same size, same side. So what I'm going to do, I'm just going to move the 2y prime over to the left side, and I'm going to move all the non y prime terms to the right. So I'm going to add this, so add the 2y prime, so minus 2x cubed y prime plus 2x squared y prime equals 2x minus 2x cubed. All right, that's just me moving everything to the proper sides. Now we have a common factor right here, and we want that on the same side anyway, so I don't know, if you have any questions, please don't hesitate to ask. You have y prime times 2y minus 2x cubed plus 2x squared y equals all this right here. Yes, I'm lazy. And so now you can divide both sides by this right here, by this term right here, and you get this didn't catch 2x. You can leave it like this. You don't have to simplify unless they specifically ask for it. And that's your answer. Any questions on how I did this? Any questions on the calculus part? All this is just algebra. Up here is the calculus part. Y'all can still see my screen too, right? Yeah, okay. Just making sure. All right, if there's no questions, I'm going to do one more of these, and then we'll move on to the quiz. Don't worry, it's relatively quick. All right, start right here. All right, I'm going to ask y'all some questions on this one. We're still using implicit differentiation. What's the derivative of e to the 2x? Anyone? Derivative of e to the 2x, it does have e to the 2x, but you're forgetting something. So it equals derivative of 2x is just 2 e to the 2x. Because if you have, say, e to the f of x equals does that make sense? The formula right there? The derivative of f of x times e to the x. So the derivative of e to the 2x is 2e to the 2x. Anyways, what's the derivative of sine? Derivative of sine is what, guys? It's a trig function. Yep, cosine. So cosine, you keep the inside the same, times the derivative of the inside of cosine. So the derivative of x is just 1 plus 3. Derivative of 3y is 3y prime. So solving for this, divide both sides by so you end up with so you subtract 1 from both sides. You end up with minus 1 plus 3y prime, or equals. So now divide both sides by 3 to get y prime by itself. So now and that's your answer. Any questions on how I did that? I know I did it kind of sort of fast because I haven't done the quiz yet because he sent it to me late last night. Any questions on how I did that one? All right, if there's no questions, we'll move on to the quiz. I should have it inserted down here already. Yeah, this is my first time looking at it too, guys, so please forgive me if I mess up. All right, so number 1, using the derivative of f of x given below, determine the critical points of f of x. All right, so what are the critical points? What are critical points, guys? Yep, the derivative is set equal to 0. So right here, this is the derivative. He already gave you the derivative, so you don't have to find the derivative. It's already factored for you too. So critical points are at x equals, or critical point. So you set x minus 6 and x equals 6. And you put so at x equals -2 and 6, you have a critical point. Makes sense. That makes sense. I'm going to move on. That was a relatively straightforward problem. And he was right when you said the first derivative test is one of the most important things you'll learn in all of calculus. Okay, so using the derivative given below, determine the intervals in which f(x) is increasing and decreasing. All right. So remember what we did here Monday or whatever? Set this equal to 0, so x minus 5 times e to the negative x equals 0. So x minus 5 equal to 0, x equals 5, e to the negative x equals 0. Is e to the x ever 0? correct. So you don't have to worry about this one. So the only critical point you have is 5. So you go over here, draw your number line. You have 5. Positive 5. So you plug in a number less than 5 to the original, or to the derivative over here that he gave you. So let's plug in 0. So you got negative 5 times e to 0, which is 1, which is negative. Let's plug in a positive number. All right. E to the, let's see, 6. So 6 minus 5 is 1, so that's positive. And then e to the negative x is just e to the negative 6 is just a really small number, so it's still positive. So therefore, it's decreasing from negative infinity to 5 and increasing from 5 to infinity. So B. Any questions on how I did that? I know I talked through it kind of sort of fast. Let me write it out over here. So I chose a number less than 5. F prime of 0 is less than 5 equals 0 minus 5 times e to the negative x, or 0, which equals a negative number times positive number. Let's do f prime of 6 equals positive times positive. So it's a positive number. If you have any questions, please let me know. Okay, find the open intervals in which the point is increasing and decreasing, and identify the local. Okay, so in my opinion, this thing is decreasing until this point, so I'd say that's -3, and it's increasing until right around 3, ever so slightly. So I'd say it's increasing from here to here, and right here on, it's decreasing. What do you guys think? And of course, it only goes from -6 to 6. Oh, and he wants to know the absolute minimum as well. At -3, the absolute minimum would be, well, since this is a closed or an open interval, but the outside, since it's an open interval, so you have -6, -2, you have -3, -3, you have 3, 3, and you have 6, 2. That's wrong. Those are all your critical points in the exact locations. This is the min and max. Since they're not on the outside, and they're the actual mins and max, the actual min and max, they're absolute mins and max on the interval. Does that make sense? Any questions on that? Oh, it's about to rain. Since the outsides are greater, or not as large as the mins and maxes, these are absolutes. So there's no questions. I'm going to move on. The largest open interval where it's increasing. All right, so to find where it's increasing and decreasing, we've got to find the derivative first, right? F prime of x using a power rule equals 1/2 x minus 1/2. Set that equal to 0. You have 1/2 x equals 1/2. And you have x equals 1. And then, since we set it equal to 0, we have our critical point. Set up 1. So we do f prime of 0 equals 1/2 times 0 minus 1/2, which equals 0 minus, which when you're not multiplying, you have to actually get the negative now, which equals negative 1/2, which equals a negative. You can do f prime of, not 0. Let's do 2. Since it's greater than 1, you can do f prime of 2 equals 1/2 times 2 minus 1/2 equals 1 minus 1/2, which equals 1/2 equals positive. All right, so it's increasing. This screen protector does not like my fingers. So it's increasing from 1 to infinity. There's only one spot where it's increasing. So the answer is A. Why did I choose 0 and 2? Because they were easiest. You have to choose something less than 1 to plug into the derivative. And 0 is usually the most helpful one. So if you can use 0, almost always use 0. And then 2, you got to choose something greater than 1 for the right side. I could have used 100. That would have been the same thing. But 2 is just a smaller number and it's easier to work with, especially since y'all don't have calculators. So I just usually choose what's easiest. He wants us, okay, that ain't that bad. So any local and absolute extreme values, if any. All right. So to find extreme values, you need to know the critical points, right? So taking the derivative of the power rule. All right, set that equal to 0. We'll pull out -3 times x squared minus x minus 12 equals 0. If y'all can't factor, y'all got to get good at it for some of this stuff. It's trial and error usually, but I can just see stuff now because of patterns I've seen in the past. So x equals -3 and 4. Those are critical points. So come over here, plot your number line. Put down your critical points. And now we have so now we need something that's less than -3. I'm going to choose -5. That was the question. You want any local min. So to find a local min and max, you got to find out where the derivative is increasing and decreasing. So equals a positive times a negative times a negative. So a positive times a negative is a negative, and a negative times a negative is a positive. So it's increasing right here. And a value that's in between 3 and 4, I'm going to use 0 equals 3 times 0 minus 4 times 0 plus 3 equals positive times negative times positive. Two positives and a negative make a negative. All right, and then when you have f prime of something greater than 4, I'm going to use 5 again, equals 3 times 5 minus 4 times 5 plus 3 equals a positive times positive times positive. So it's increasing on that interval. All right, so I got a question for you guys. What does it mean when a value goes from increasing to decreasing? What does that mean you have at the very least? Correct, you have a local max because your equation will look something like this, and then it'll start decreasing again. There's your local max. And what does it mean when you go from decreasing to increasing? Correct. Local minimum. So according to this, we have a local maximum at x equals -3 and a local minimum at x equals 4. So your correct answer is A. Any questions on how I did that? Any at all, because this is a very important concept. All right. There's no questions. I'll move on. Okay. Identify the function's extreme values in the given domain and say where they are assumed. Tell which extremes value, if any, are absolute. So you have a domain of -infinity to 4, and you want to know the extreme values. So first off, what do? We take the derivative. Y'all know this by now. I still don't remember to change my pen. 2x minus 4. Set it equal to 0. X equals 2. So you have a critical point at x equals 2. 2. Now actually, four. So if we plug in a number less than 2 into the derivative, f prime of 0 equals times 0 minus 4 equals negative. Plug in a number between 2 and 4, because we have domain between -infinity and 4. 2. I set 2 minus 4 equal to 0. The derivative set it equal to 0. So you'll have, okay. And now we need a number between 2 and 4, so I'm going to do f prime of 3 equals 2 times 3 minus 4, which equals 6 minus 4, which equals positive 2. So that's increasing. All right, so since it's decreasing to increasing, we have at a very least a minimum at some sort because of this. So now we have to test the values of everything. So now, since we have the domain, we have to check everything. There's not enough room. I'll go over here. We have to plug in every value, every critical point, and every value in the domain, or every endpoint in the domain. So f of -infinity to the original equation, I might add, not to the derivative, to the original equation. Infinity equals infinity squared minus 4 times infinity. So that would be infinity squared minus 4. So I'm assuming that's approaching -infinity. I'll put that in the Desmos just to be sure. I'm wrong. That's positive infinity because you have well, first off, we don't even need to know that, but you have an x squared, and since it's a positive in front of the x squared, it's going to be a regular parabola, like so. It's going to look something like that. So equals infinity. And now we got to plug in our critical point. So f of 2 equals 2 squared minus 4 times 2. Now we got to plug in our other endpoint, and yes, that one's the actual thing. So equals 4 squared minus 4 times 4 equals 0. All right, since that equals 0, we have a minimum value at -4 of -4 at x equals 2. And it's not since it's a parabola, it only changes direction once. So we know it's an absolute minimum. So there is an local and absolute minimum at -4 at x equals 2. And I guess a local maximum since you're in the domain of 0 at x equals 4. I guess that's what they mean by that. It's not an absolute maximum, it's only a local maximum. That's what he was trying to mean. Y'all understand what I did there, kind of, sort of? I did my number line over here to the right, and then I plugged in the endpoints of the domain and the critical points to the original equation. Any questions on how I did that? Well, okay, this is just from prior knowledge, but see how this is a parabola right here? It's a parabola where where it crosses the x-axis at x equals 0 and x equals 4, because if you factor it out, and those are your two zeros, x equals 0, so x equals 0 and x equals 4. So since it's a positive parabola, since this is imaginary a and a is greater than 0, oof, oof, a is greater than 0, you know that it's pointing upwards, and the two endpoints will be at infinity. All right, and since they're going to infinity, you know there has to be a minimum, and there's always the minimum in between the two endpoints. Am I making any sense or just confusing you more? Well, if you look over here at this means it only changes direction one time. This means that the function only changes direction one time. So there is only one minimum in the entire equation. And since there's only one minimum in the entire equation, then it's an absolute minimum. Because it'll never go from maximum and go down again. The same goes if it was only one maximum in the entire equation, that would be the same thing. Any other questions? All right. If there's no more questions, I'll move on. Find the absolute maximum minimum values of f of x equals natural log of sine x. Oh, wow. Okay, so we have our endpoint. So we'll do f prime of x. What's the derivative of natural log of x, guys? Correct. 1 over x. So you just do 1 over sine x times the derivative. Draw my boxes here. 1, 2, 3. Times the derivative of that, which is cosine x, times derivative of x, which is 1. So that equals cosine x over sine x, which equals tangent of x. Or cotangent, 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 cotangent. So now we want to set cotangent of x equal to 0. Oh, that's fun. So what this is saying is, when does cosine, since cosine is on top, and sine, because remember, whenever it's a critical point, whenever the derivative is undefined or equals 0. So cosine of x equals 0 at pi over 2 and 3 pi over 2. Sine x equals 0 at 0 and pi. That makes sense? Hang on. So now we have so we got to make sure when the top equals 0. So or do the denominator 1 to sine x equals 0. I'm trying to make it a bit more clear for you guys. All right. So this one is undefined for the sine x and when it's 0. But you have a domain, right? So you have pi over 6. And you have 2 pi over 3. Which of these values are between pi over 6 and 2 pi over 3? Well, if you go to the unit circle, 2 pi over 3 ends right here. So 0 is less than pi over 6. 2 pi over 3, pi is greater than 2 pi over 3. So your only other critical point is pi over 2 on the domain. And so come over here. Now we have our number line. Prime of so we need a number between pi over 6 and pi over 2. I want to do pi over 4 of equals cotangent of pi over 4 equals cosine pi over 4 equals sine pi over 4, which equals so equals 1. Now we need a number between pi over 2 and 2 pi over 3. That's tricky. But since this is positive, I have positive right here. I don't know any values off the top of my head between pi over 2 and 2 pi over 3. I'm going to type it into a calculator. Cosine of pi over 2. So I'm cosine of 2 because 2 pi over 3 is greater than 2. So cosine of 2 over sine of 2 is negative. So that's negative. So let's do so it's negative. That's all that matters. Yeah, I really don't know a number off the top of my head between those two. So now you know where it's increasing and decreasing. But that's not it. Now you have to check all three of these values to the original equation. F of x equals natural log sine x. And that equals natural log of, so we'll do f of pi over 6 equals natural log of natural log of 1/2. Personally, I don't know. I think it's a really small number. No, it's not really small. Negative 0.693. Let's do f of pi over 2 now. Equals natural log of sine equals 0. And let's do If I'm going too fast, please stop me. I don't know how I expect y'all to do this without a calculator. Sine of 2 pi over 3 is 1/2. Never mind, I'm wrong. Sine of 2 pi over 3 squared root of 3 over 2. It's still negative. So here are your 3 values. Your absolute, you have a local max at x equals 0. And from the looks of it, it only changes direction once in this. So you have an absolute max over the domain at x equals 0. And it said absolute max and mins. And you have an absolute min at negative 0.693. Oh, I guess negative natural log of 2 works. You got a max of 0 at x equals 0, or a max, yeah, at x equals pi over 2. That works right here. And you have a minimum. This is natural log of square root of 3 over 2. Wait, no. It's x equals pi over 6. That's natural log of 2. Okay, this is wrong right here. Yeah, this is equal to negative natural log of 2. How are y'all supposed to know that? I have no idea. That's equal to negative natural log of 2 at x equals pi over 6. So the answer is C. Did y'all know that off the top of y'all's heads? Or did y'all have to use a calculator on that? Anyway, is there any questions on how I did that? At least, yeah, I would have guessed it eventually, because you didn't really need to know this value right here. You just needed to know that x equals pi over 6 and this one right here. But yeah, that's ridiculous. But any questions? Yeah, it was a lot. First, the finding the derivative wasn't too bad, but then having to realize that whenever the denominator is undefined, you have to have a critical point too. You had to remember that. And then plugging in all the values. So this is for a different equation. Yeah, this is a whole new equation down here. See, that was a bit of a tough one. So maybe y'all can come back and look at all this and how I did it again and pause. We only got like what? We're on number what? 8? Oh, we got 15. I gotta hurry, guys, if y'all want to finish. I didn't know this quiz would be so hard. So this is the mean value theorem again. So between these two endpoints, there is a point of f prime of c where the slope is exactly, the derivative at a point is the exact slope of the secant line. So, oh, she left, okay. We'll do f, we gotta take the derivative. And now plug in c. So now we just find f of -1 equals 1 minus 3 plus 1 equals -1, and f of 2 equals 4 It's 12 plus 1 equals 17. So now we do plug in where we have f of c, f prime of c, plus 3 equals 17 minus negative 1 over 2 minus negative 1. So 2c plus 3 equals 18 over 3, which equals 6. 2c equals 3. C equals 3 over 2. Wait, how did I do this wrong? Okay, apparently I did this one wrong. That's 3 times 2, not 3 times 4. C equals 1/2, guys. Sorry about that. Any questions? I just found all the values and then plugged them all into the formula he gave you so graciously up here. If there's no questions, I'll move on to try to finish for you guys. There's an absolute maximum. The derivative doesn't exist at a point, but that means it's undefined. So there is an absolute maximum only at right here. I think, did y'all do this one and get it wrong? Or was that the correct answer when y'all took the quiz? Well, on interval A to B, I would think that's right. Only thing is, it's not continuous over the whole domain because you have this little dot down here. There could very well be no absolute extrema. But I think there's the absolute maximum only. That's what I would assume. Well, you know what they say about assuming. All right. Found the indicated absolute extrema. So you have an absolute min down here. And this goes on forever and ever. So your smallest value is at x equals -2. Make sense? And it's continuous over its whole domain. I'm going to keep going so I can try to finish for you guys. Find the graph that best matches the table. So it's decreasing to at least f prime is 0. And increasing when you get to f prime of 2. So it changes the direction once. And this is the derivative, right? You know, assuming that means prime. This one's decreasing over its whole domain. This one's increasing from the left and decreasing from the right. I don't like this right here because at x equals negative or like 1.5. It's negative 1.5. That's why. Yeah. Okay. Okay. So the correct answer, since it's decreasing to 1.5 and increasing after that, F2, it's increasing. So therefore, and it's a parabola because it only changes direction once so far. And it works at those. And at 1.5 is a critical point, right? Because the derivative is equal to 0. So that's how you know the it's change of direction right here. Because it's equal to 0, it's a critical point. Move on. Do y'all have any questions about that, or y'all want me to go ahead and move on and finish this? I'll go ahead and finish it. So find the absolute extrema from the endpoints. Okay, so f prime of x equals 4 over x cubed. Y'all want to see me take the derivative of this, or just let me keep doing my thing? Because if this equals which equals that. But so now we have our one critical point where it's undefined at x equals 0. So now we have 0. And we have our endpoints, not arrows, endpoints. So we have, so now if we plug in a negative value in the bottom, we're going to have 4 over, let's say, a negative number cubed. Right, 4 over a negative number cubed. It's still going to be negative. If we do 4 over, let me put a circle around that. See how my notation's similar. Positive number cubed is going to be positive because when you cube something, it keeps the same sign. So this means there is an absolute, or this means there is a local minimum in the area. So now you just plug in f of negative 0.5. Oh, that's 0.5 to 5. Oh, crap. Never mind. Okay. So you have your domain. And 0 is your only critical point, right? So 0 is not on this domain, so you don't have a critical point. So you only have to check the 2 endpoints. So your absolute minimum is negative 2 over 25 at x equals 5, and your maximum is negative 8 at x equals 0.5. And actually, this is a max. Since it's closer to 0, this is your max, and this is your min. The correct answer right here is A. All right, let me move on. We're on 13. We're almost done. On the absolute extreme of the function on the interval. So secant squared of x. So 1 over cosine x equals 0. cosine 0 at x equals pi over 2 and 3 pi over 2. And neither of those are on this interval. So you only have the interval, because pi over 2 is greater than pi over 6, and negative pi over 2 is less than pi over 6. Negative pi over 6. So, and then you only have to check the endpoints. So f of negative pi over 6, so tangent. I'm using the calculator, sorry. Is negative root 3 over 3. And this will be just making y'all use trig more. Sorry if that sound really hurt y'all's ears. So minimum negative root 3 over 3 at negative pi over 6, and a maximum. Let me move on real quick. Find all the critical points. So critical points is when you set the derivative equal to 0, or if it's undefined. So f prime of x equals simplify as much as you can. You can pull out a 3x. When you set that equal to 0 in the factored form, you get 0 and 2. Please, if you have any questions, do not feel afraid to stop me. Find the extreme values, so you got to find the derivative. So you get your two critical points. And you draw out your number line. So, and now let's do f prime of negative 3 equals, that'll be 27 minus 12 equals, that is 3 cubed minus 12. That's just going to be positive. I'm just going to leave like that. And we're going to do between negative 2 and 2 equals negative, because it's just negative 12. And then so this is a max. This is a min, because when it goes from increasing to decreasing, it's a max. And when it goes from decreasing to increasing, it's a min. And since there is no domain, and this changes direction twice over the entire domain, there is no absolute min and max. It's going to end at two different spots. Like one side's going to be going to negative infinity, the other side's going to be going to positive infinity. So you have a local min at negative 2 and a positive, and a local max negative 2 and a local min at positive 2. So without plugging them in, you can just look at the equations. Normally you'd have to plug these in to the original equation. So you'd have to do y at x equals negative 2, and that would give you 18. And then y at x equals 2 would give you negative 14. All right. Any questions over all this? I know I had to hurry towards the end. Some of these were a bit iffy. if that's all the questions y'all guys have, that's all the time we have today. Y'all are welcome to come for office hours tomorrow. You want to do related rates? I can pick a couple problems for tomorrow if you want to come to the office hours, or yeah, Monday we can do related rates and get a couple of those problems. I don't know if I did them already, but yeah, Monday I can plan a couple of related rates at the beginning. So if that would help y'all. Um, all right. If there's no other questions, I will examples. Okay. Let me write a quick note. What examples did he tell you about? Do you remember? Examples 4 through 6. Oh, the examples he went over Monday. Yeah. All right. Monday we can do those. We'll go through those, and then after those, I'll go over the quiz. Does that work for you guys? All right. Jaquez, if you have a question, you can ask me real quick. But I just finished the um session, so you can go back and watch it on YouTube. It'll be up in a couple minutes, or that'll be ready here, and even sooner if you just want to click on it through Teams. Oh yeah, I'm sorry, bro. I got office hours tomorrow at 2 if you want to stop by. All right. Hope I had to go fast towards the end. So, all right, guys, if that's it, I will catch y'all later. Thanks for stopping by.